Okay, so when you think about solar panels, right, you probably picture bright sunshine, blue skies, a perfect day.
Yeah, that's the ideal image, definitely.
But that makes you wonder, what actually happens when the sun isn't shining, like during rain? Today we're doing a deep dive into Kansas City, Kansas.
Hmm.
It's a really interesting solar hub, especially when you consider it's very changeable weather. How do panels actually hold up there?
Yeah, what's fascinating really is how the technology adapts to the real world, not just those perfect lab conditions.
Right.
So today, our mission is to understand that resilience, the innovative ways solar tech handles challenging weather, particularly rain. It's about showing you how this knowledge actually translates into reliable energy for your home or business.
Okay, so starting with the basics. We all know solar panels convert sunlight to electricity.
Hmm.
That's their job.
Mm-hmm.
But here's something that might surprise you. They do keep generating power in the rain. Now, it's less efficient, sure, maybe 10 to 25% of peak capacity if it's really overcast.
Right, it's reduced.
But get this, rain can actually help long term.
Yeah.
It washes off the dust and grime.
Cleans the panels naturally, which improves performance over time, surprisingly.
Exactly. Who would have thought rain could be, well, helpful?
So this brings up a really important question. How do we make sure these systems are reliable when you have such variable conditions?
Yeah,
Kansas City is a great example. They get around 215 sunny days a year, which is pretty good for solar.
that sounds decent.
It is. But they also get extremes. Heavy thunderstorms, even tornadoes, plus winter snow. So rain and clouds obviously cut output temporarily. Summer heat, that can cause a bit of thermal degradation where panels get slightly less efficient when it's super hot.
Okay.
And winter snow, if the panels are flat, can just block the sun entirely. Plus, you need really sturdy mounting because of the wind and potential hail.
That makes sense. You need robust gear. And that leads perfectly into this specific case we saw. A 12.4 kilowatt residential system in KC.
Okay.
On one really heavy rain day, its output dropped to just zero point 0.1 kilowatts.
Hey.
Tiny.
Wow, yeah, that's a huge difference from a sunny day.
Right. So if you're relying on that power, what do you do? What are the solutions for bridging those gaps?
Well, this is where it gets really interesting, where the innovation comes in.
Okay.
First, battery backups are crucial. Things like the Tesla Powerwall. They store the extra energy you make when it is sunny.
So you have power at night or during those rainy spells?
Exactly, continuous power. Then there's the panel tilt. It's not just about catching the sun. Tilting them helps shed snow and rain and debris.
Ah, clever. Simple physics.
Yep. And grid interconnection is key too, net metering. You send excess power back to the grid, maybe get credits, your house becomes like a mini power station.
That helps balance things out.
It does. And beyond that, we're seeing some really advanced stuff. AI monitoring, like efficient net B0, can spot problems like delamination layer separation in real time.
So you fix problems before they tank your output.
Yeah.
Proactive, not reactive.
Precisely. Maximizes the system's life and output. We're even seeing solar used for, like, water management in aquaculture, keeping koi ponds aerated.
Really? Solar-powered fish ponds.
Yeah. And things like special reflective setups to boost light capture when it's really dim. Lots of smart adaptations.
So it's not just about the panels themselves anymore. It sounds like a whole system, an ecosystem of solutions. What does this all mean for Kansas City's solar scene overall?
It means their solar ecosystem is actually thriving despite all those weather challenges we talked about.
Impressive.
And it's not just the tech. Policy plays a huge role. The 30% federal tax credit, for instance, that makes it much more affordable and less risky for homeowners.
Lowers the barrier to entry.
Absolutely. Plus, you have strong local installers like Cromwell Solar and SunPower providing the know-how. And innovative designs are popping up too, like solar awnings. Simple, but effective.
So it's a combination of tech, policy, and local expertise.
Exactly. That combination drives the resilience. It ensures reliable energy, even when the sun isn't playing ball perfectly.
So the big takeaway seems to be that solar is way more adaptable and resilient than many people might think. It performs pretty well, even when conditions aren't ideal.
That's right. And, as we wrap up, maybe here's something for you to think about. As we push harder for more renewables everywhere, how can these kinds of localized climate challenges and the specific tech solutions we see in places like Kansas City, how can they help shape smarter energy strategies for other regions with their own unique climates?